Hello and good day. For today, we will talk about three different examples of an electromagnetic devices. This will be the galvanometer, electric motor, and the electric generator. First, let's look and let's find out how they function or what they mean. A galvanometer, it is an electromechanical instrument. Electromechanical, which means in engineering, electromechanics combines processes and procedures drawn from electrical engineering and mechanical engineering. Electromechanics focuses on the interaction of electrical and mechanical system as a whole and how the two systems interact with each other. It is an electromechanical instrument, and it is used for detecting and indicating an electric current. A galvanometer works as an actuator. What is an actuator? An actuator, it is a component of a machine that is responsible for moving and controlling a mechanism or a system. And for example, the opening a valve. In simplest terms, it is a mover. By producing a rotary deflection of a pointer in response to electric current flowing through a coil in a constant magnetic field. Early galvanometers were not calibrated, but improved devices were used as measuring instruments called ammeters to measure the current flowing through an electric circuit. A galvanometer's difference from the electric motor and the electric generator is this is a device for measuring the current and the movement of the electricity that is flowing. Let's move on to the two electric devices. Electric motor. An electric motor, it is an electrical machine that converts electrical energy into mechanical energy. And most electric motors operate through the interaction between the motor's magnetic field in a wire winding to generate force in the form of torque. Torque means, in physics and mechanics, torque it's referred to the rotational equivalent of the linear force. It is also referred to the moment of force, rotational force, or the turning effect depending on the field that you are studying. And this, again, the motor's magnetic field and electric current in a wire winding to generate force in the form of torque applied on the motor shaft. Electric motors can be powered by direct current sources such as from batteries, or rectifiers, or by alternating current sources such as power grid inverters or electrical generators. For the last one, we have the electric generator. In electricity generation, a generator is a device that converts motive power. Motive power is a mechanical energy into electrical power. It is the reverse or somehow the opposite of the electric motor. In electric motor, it turns electric power to mechanical energy. But in electric generator, it turns the mechanical energy into electric power. The uses of it is in an external circuit. And the sources of mechanical energy includes different types of turbines, such as steam, gas, water, and the wind turbines, and also internal combustion engines. Crank can also be the source by applying physical and manual force. The first electromagnetic generator is one of the famous inventions, which is called the Faraday disc. So it is invented by the famous British scientist Michael Faraday. So the difference between these three is galvanometer is the most different from the three. So because it is a measuring device, it is measuring the current and the flow of the electricity. Meanwhile, the electric motor and electric generator is just the ones that are using those energy. Electric motors, is what I've said, it turns electrical power into mechanical energy. And electric generators turn mechanical energy into electrical powers. So, and I forgot to say that electric generator is famous about its function as the type of source of electricity when we're having a brownout or a blackout in our community. And electric generators are the main source of electricity in these times. So I hope that I explained it thoroughly and you get it or you understand what I've said. So thank you.